use variation of parameters to solve a given system. So here's the steps you need to do in order to find the solution for using variation of parameters method. So first you need to find any homogeneous solution, then you need to find non-homogeneous part and add them together, which gives you final answer. Okay, so here's the steps, and it's not a step-by-step process, but I will walk you through it when we look at a specific problem. Let's put this aside. Okay, so here's your problem. First, same as usual, you need to have a minus lambda I. Let's call this matrix A subtracted with lambda I. That gives you this matrix. Then find its determinant. It gives you this matrix. Okay, distribute this out, simplify it, set it equal to 0. So for lambda, you will get 0, 2, 3 for lambda. That is your eigenvalues. Now for each eigenvalue, you will get an eigenvector. Let's find out what those are. For lambda equals 0, plug it into a minus lambda I, gives you this matrix augmented with 0. Okay, now if I reduce it down to base matrix, I will get infinite solution, and my vector k is equal to k1 is equal to negative k2, k2 is k2, k3 is 0. And if I pull out k2, I will get negative 1, 1, 0, and my vector x is my vector x1 is negative 1, 1, 0, e to the 0, which is 1. Okay, now you're going to do the same thing for lambda equals 2. Plug into a minus lambda I augmented with 0, reduces down to base matrix. Similarly to lambda equals 0, your vector k here is equal to, for the first row, you have k1 equals k2, k2 is k2, right? It's everything. K3 is equal to 0. Pull out k2, you have 1, 1, 0 vector. Then vector x2 is equal to 1, 1, 0 times e to the 2t. Okay, here's why you have e to the 2t. Now for lambda equals 3, plug it into a minus lambda I, augmented with 0, reduced to base matrix. You will have a vector k of 0, 0, k3. Then if I pull out k3, I will get 0, 0, 1. Then my vector x3 is 0, 0, 1 e to the 3t. Then my homogeneous solution is equal to c1 times vector x1 plus c2 times vector x2 plus c3 times vector x3. That is your homogeneous part. Now for non-homogeneous part, similarly like a minus lambda I, you need to have a matrix which I call phi of t. And for this matrix, it's basically you take down the vectors time the t function. Well, basically you exclude c1, c2, and c3 and put out the rest. Okay, you have this matrix. Then you need to find its determinant, which gives you negative 2 e to the phi t. Then you find its inverse, which is equal to 1 over the determinant time the adj of this one, adjacent adj of this matrix. So let me show you how did I get this matrix. Okay, so let me see. Okay, I'm gonna use the sheet over here. So the first step you need to do is to, so from this matrix phi, let me put this up a little bit. Okay, so first looking at this matrix, so you already found the determinant of it, which is this one. Now to find the inverse of this one, you need to find a cofunction of this matrix. So let's take a look at the first entry, right? So for the first entry, cover this row, this column, and this row. You left with this matrix, e to the 2t, 0, 0, e to the 3t, right? That is your first entry. Now for your second entry of the first column, block this row and this column. You left with matrix 1, 0, 0, e to the 3t. Okay, doing the same thing for the third entry of the first matrix. Block this row, block this column. You left with this matrix, which is 1 e to the 2t, 0, 0. Okay, now you're going to do the same thing for the rest. So I'm gonna skip over it. Alright, and then the next step is to assign their size. So starting with positive, so you are going to alternate the size. It's positive, negative, positive, positive, negative, positive. Always start with positive, okay, no matter what. That's the convention. Now over here you have negative, then positive, negative, positive, then negative, positive. Okay, now simplify this one. So for this one, find the determinant of this one. It gives you e to the phi t. For this one, it gives you negative e to the 3t. This one, 0, of course. Now for this one, you have negative e to the 5t. This one, negative e to the t3. This one, 0. This one, 0. This one, 0. This one, negative e to the 5t. No, negative 2e to the 2t. Okay. And then the next step is to find the transpose of this one. How? So look at the first row. To transpose this one, you are going to take this row and put it into a column. Okay, so you have this row. Basically, you take this row and then you put it into a column like this. So you twist this down. Okay, so you have e to the 5t, bring this down, negative 3, negative e to the 3t, and 0. Okay, now for second row, twist this down to make it become a column. To make it your second column, so you have e to the negative e to the 5t, negative e to the 3t, 0. And for your third column, similarly, make this become your third row column. 0, 0, negative 2e to the 2t. Okay, so that's why. So this is how I got this matrix. Okay, so they look exactly the same. All right, now multiply by 1 over the determinant. It gives you this matrix, and then you need to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is this matrix, this one, whatever beyond x, vector x. Okay, so multiply them together, which gives you this matrix. Okay, so here's a little note here: do not switch their orders, because multiply matrices together, there's no commutative rule for matrices. A times b is not the same as b times a. Okay, keep in mind that once you have this matrix, integrate this one, it will give you u of t, which is this matrix, and then your non-homogeneous solution is equal to phi of t times u of t. Multiply them together, it will give you this matrix. Simplify it, you will get this matrix. Again, when you multiply matrices together, do not switch their order, otherwise you will get a different or incorrect answer, and your final answer is equal to homogeneous part plus non-homogeneous part, which is this long answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.